This is video number 2 for sections 1.3 and 1.4, types of slope. There are exactly 4 different types of slope that you might run into as you're going through the material, and that is because there are exactly 4 different types of lines. We started talking about this a little bit in the last video. Let's run through them. The first type of line is what's called an increasing line, and that just means that it travels in an upward direction from left to right. The left to right part is important. As I move along from left to right, this line is heading upward. Well, if I wanted to calculate the slope of this line, I would have to pick out a couple of points. And if I started here, clearly I would be traveling to the right as far as my run goes. That's a positive value. And I would be traveling up as far as my rise goes. That's a positive value. Well, a positive divided by a positive is a positive. And so anytime you have an increasing line, what you want to remember is that the slope is always positive. What about a decreasing line? Well, a decreasing line simply means a line that is heading downward from left to right. So as you travel along left to right, the line is heading down. If you started to mark rise and run information, again, I just need to pick some first point and some second point. Well, if this is my first point, I would travel down. That's a negative direction. I would travel right. That's a positive direction. A negative divided by a positive is always a negative. So for decreasing lines, we say the slope is always less than 0. The slope is always negative. Okay, what about horizontal lines, right? Those lines that just go perfectly sideways. What can we say about the slope of those lines? They're certainly kind of funny. I mean, they're just extremely flat, right? They're as flat as you can get. Well, again, if I pick out a couple of points, let's say that's my first point, and this is my second point. If I think about how to get from the first point to the second point, one thing for sure is I don't go up or down. In other words, I have no rise in this problem. My rise in this problem is 0. I only go to the right. So that would be some kind of positive number. My run would be positive. My rise would be 0. That means when I went to calculate the slope, I would have, remember it's rise over run, 0 divided by some positive number. Well, 0 divided by any number is just 0. And so what we've just learned is that for a horizontal line, the slope is always 0. I recommend you just memorize that so you don't have to calculate it every single time. It makes good sense, right? I mean, the line is totally flat, and so the slope is 0. Now, what about a vertical line? A vertical line, of course, a line that's running just straight up and down, very, very steep. What's going to happen to us when we try to calculate the slope here? Well, again, let me pick a first point and a second point. If I tried to think about how to go from this first point to this second point, I am not going to go left or right any. That means this time my run is equal to 0. I can't even make one of those little triangle pictures. I can only just go straight up. So my rise would be positive, my run would be 0. So when I go to calculate the slope, I would have some positive number on the top divided by 0, my run of 0. Well, this is a big problem. You might remember from earlier in your math career that dividing by 0 is an impossibility. 5 divided by 0, 6 divided by 0, it just doesn't exist. You can't take something and divide it into nothing. You can try it on your calculator. It's just going to say error. We tried to follow our little formula here, and we're getting something that's impossible. And so what we end up having to say is that for vertical lines, the slope is undefined. That's just a fancy way of saying it doesn't exist. We tried to calculate it, and we simply couldn't. Vertical lines don't even have any slope. It just doesn't even exist. Now, a lot of times people get these two slopes mixed up for horizontal lines and for vertical lines. Horizontal lines, they do have slope. It does exist. The value is 0. Vertical lines, they don't have any slope. The slope is undefined. Saying no slope is not the same as saying, yes, there is a slope of 0. If you struggle to remember, just think about skiing. Okay, these diagonal lines we drew up here, you could ski along those slopes, right? That's certainly possible. What about a horizontal line? Well, you can ski across a horizontal line. It's called cross-country skiing. It's a lot of work, but it is possible. You can do it. Okay, there is a slope. It's just a slope of 0. Well, if you tried to ski down a vertical line, that would be called falling, right? I mean, that's just not possible. There's no slope to hang on to there. You just fall right down there. So vertical lines, they don't have any slope. It just doesn't exist. Maybe that will help you remember. Well, to close off this little part here, let's just sum up by using this last example here. Let's say I told you that I have a line and the slope of this line that I have is -1/8. Now, that's not enough information for you to draw a complete graph or even come up with any points on the line, but you can tell me a couple of things. First off, what you should notice is the slope is negative. Well, as we saw, anytime you have a negative slope, that means you have a decreasing line. So that's one thing I know without even looking at a picture. Secondly, I concentrate on the value of the slope. Remember in our first video we said that bigger values correspond to steeper lines, smaller values correspond to flatter lines. Well, 1/8 is a pretty tiny number, right? It's a small number, and so what that tells me is that this line must be somewhat flat. If I were to try to draw a quick picture of this line, again, I don't know exactly where to place it. I'm just in my mind thinking it probably looks something like this. It's definitely heading downward, it's decreasing, and it is fairly flat. Be sure you are working hard on understanding the connection between the slope and the eventual picture of the line.